So today I'm going to talk about more of what Sir was talking. I'm going to build up on top of that. So since we are on the lines of RAG, which is becoming like sort of like a state-of-the-art technology, like I wouldn't really call it a technology, but sort of like an infrastructure, right? Or an orchestrator for things to work. So I'd like also to touch on RAG before going forward. So I'm actually going to be speaking on GraphRAG, which is a little bit different from your regular conventional RAG, right? So your conventional RAG works basically by having a vector database behind the scenes, right? So your vector database is what is powering your regular RAG. And whether it is agentic RAG, you have a couple of tools along with it, right? So at the end of the day, it all comes down to prompt engineering. RAG is just a prompt engineering technique wherein we are adding a couple of information before we pass it on to the LLM. That's all we are doing. Fine. Before I go ahead with GraphRAG and Neo4J and all these things, I'll quickly just go ahead with RAG, right? So as I told you, RAG is just a basic prompt engineering technique. What is prompt engineering? When you actually modify your prompt so that your LLM can actually infer something out of it, right? So for example, you give some examples or you give some additional knowledge to it, right? So when you have a private data set, right? Like let's say, I'll run through it and you'll understand what I'm trying to say. So usually LLMs in general have a knowledge cutoff date, right? Till when they are trained upon. So anything after that is basically hallucination. So either it is predicting what is happening after that, or it is straight up hallucinating. Yeah, they are general purpose models, and they may not be up to date. So they may not also understand your company's data, right? So I start a company tomorrow, right? And I cannot expect ChatGPT to understand my workers or my employees or my framework, right? If I want to build an internal chatbot for my team, I cannot rely only on an LLM, right? That's where a prompt engineering technique like RAG comes in. So what does it do? So an oversimplified example. So we'll assume that the last one is a robo, like tried to draw it on my own, but it didn't come, well. So this is what actually happens behind the scenes. You have a user query coming in, right? And what happens is that usually that user query directly goes to the LLM, right? When you query ChatGPT, right? What happens? That user query directly goes to, it's like 1 to 4. But here we have like a rerouting wherein before it goes to your LLM, it fetches additional information related to what you're querying about. Then it adds to the original user query. That's what is happening at 3. Then it passes to the LLM. Then you get the response. If it was a regular chat GPT, right? You'll get 1 to 4 directly and 4 to 1. So that's the difference which we'll notice over here. So see, this is a pretty standard example, right? So I asked ChatGPT, who is Karthick Durai, right? So there's no way it knows who I am, right? Unless I'm some celebrity or someone popular, it wouldn't know about me, right? What I do now is that I create sort of like a fake data. Like let's assume this is the data I've created. You can see like name, age, department, designation. So it's similar to an SQL layout, right? An SQL table layout, if you're familiar with that. So if you see over there, there's my name, my department, my age, and all those things. And below that, I have a complaint ID. So what I'm trying to replicate over here is that when you have a RAG system in place, you'll get information from different places, right? One might be the first might be my employment information, right? The second and third might be the HR related complaints, right? Users can usually lodge a complaint to HR regarding certain facilities. So here I have complained that, I don't get a parking spot allotted for myself, right? So now what happens? Now I ask the same, it's the same bot, right? ChatGPT, I ask it again, but with newer information, right? Now I get a better response because now it actually knows about me. This is what we are trying to achieve, whether it is GraphRAG or your conventional RAG or any sort of like RAG system. You're actually trying to build up a system which can actually understand your data and respond only with that, right? You don't want it to hallucinate. Now again, RAG sounds interesting, but there are some fundamental issues with RAG. That's why, Sir was also talking about like agentic RAG. New RAG systems have come in place because of some of the downsides of regular RAG, right? So what are some of the downsides? If you think about it, one is that it relies on a vector database, right? It's better than a lexical search wherein it goes and searches your, word-based retrieval, right? Keyword-based retrieval. It's better than that, obviously, but we cannot guarantee that whatever is contextually matching is supposed to be the right data, right? It might not be always be the case. So I'll show that also with an example. Second, usually when you want to understand your entire data as a whole, right? For example, I have fed my company's profit loss statement, for example, right? Financial statement I've submitted to it. And I'm asking for it to generalize and tell me back, like how did my company do for that financial year, right? So what is actually going to happen? It's going to go here. It's going to make a vector database call, right? And it's going to try to match what is contextually matching with financial data set for the year, right? It might not get the whole data set, but it might get some bits and pieces, because data set usually is not, like, for example, if it is a 100-page PDF, I cannot push it once, everything to chat GPT, right? Or GPT, any LLM for that matter. So usually LLMs have a token limit. So I have to stick within that. So because of that, we usually chunk the data into smaller pieces, bits and pieces. So I'm pretty sure if you do this, and if you ask it to ask, like, can you summarize the entire financial year? How did my company do? There's no way it's going to tell you the entire picture, right? It might give you bits and pieces of information, but it might not give you the entire picture. So that's what we are trying to solve. So we are trying to build a sort of like a different RAG system, which can address that part, wherein it can understand your entire data holistically and also give you a better picture, right? And what better way to understand than a graph system, right? Because knowledge graphs are known for relationships, and basically it's edges and nodes and edges, right? So once you are at a particular node, you can do like whether it is a DFS or BFS, like any type of like graph system allows you to iterate through, all the nodes through the relationships, right? So that's one thing which is very strong in GraphRAG, or I should say knowledge graph, is in you have a very strong relationship established already, right? So that's what I see as the plus point over here, right? And there are like 3 types of queries, or I should say like 2 types of queries wherein your GraphRAG works really well. One is depth-based queries, and second is like breadth-based queries. Now, what is depth-based queries? For example, I want to know for a particular year, right? I have uploaded my financial, financial sheet, right? A balance sheet for like past 4 years. I want to know for a particular month in 2021. So how do I do that? That is a very specific question, right? When you want a very specific question, you go with a depth-based query, right? Second is a breadth-based query. Breadth-based query is when I want to understand for the past 4 years, how did my data set do? And majorly all other queries lie somewhere in between. It's a hybrid of like either breadth or depth. Fine. So now we come to GraphRAG, and so let's do a small thought experiment. We'll try to figure out like what GraphRAG actually comprises of, right? So what I'm actually trying to do over here is that I'm not actually trying to say this is how GraphRAG should work. I'm just giving you one possible structure, right? There are many different ways to implement GraphRAG. This is just one structure which we have implemented at my company. Fine. So if we go here, right? So usually GraphRAG has GraphRAGs have 2 major parts. One is when you want to index your data, right? What is my data? My data is my company's balance sheet, right? I have for the past 10 years. I want to index it somewhere, whether it is a vector database or a graph database. Indexing should happen in all RAG systems. So the first part is like when I index my data. Second part is when I retrieve the data back, right? So the indexing has a lot of different, that's the reason why I gave it the title thought experiment. There are different ways to index it, right? I'm just giving you one way to index your graph system. So you take your unstructured documents. What are those? Those are just PDFs or text files, your CSVs, MongoDB collections, and all those data sources, wherever your data is sitting. You take all those data sources and you make chunks out of it, right? And you do something called entity extraction. We'll come back to this, but stick with me. We'll do something called entity extraction, and we'll do entity description summary, right? So till this part, what we are doing is that we are building the knowledge graph. So what does a knowledge graph need? So if I take this example, right? Let me take an entity. Okay, so this is what happens after you run all that I've said, but I'm just showing you so that it makes sense, right? So it is basically saying that these are different chunks, right? Chunks are the ones over here, right? Text blocks, right? This might be a very long document. I've broken down into smaller text pieces, right? And all these chunks have this entity in common, right? What is this entity? The entity is like about a person called Paul Graham, right? We are taking Paul Graham's essays as example over here. So we have a nice little description also. So this description tells us what is it about. Fine. So how do we do it? We do it using this step, the entity extraction part. So what actually happens in entity extraction? Entity extraction is going to iterate through all the chunks. Fine. It's going to iterate one chunk at a time. Let's say you iterate through a particular chunk, and this is the chunk, for example. Right? This is the chunk, for example. So what it is going to do is that I'm going to pass a prompt and I'm going to ask it to extract all the entities, right? Whether it is GPT, whether it is Llama, whether it is like Mistral, I'm just going to pass this entire text to it and I'm going to ask it to extract all the entities out of it. So usually your prompt looks something like this. Fine. So if it's a bit shabby, but like it says that given a text document, extract all potential entities and relationships. Fine. This is a prompt which I'm making so that I can extract entities out of my document. Fine. Does that make sense? So at the end, I'll get something like this. I'll get the entity name, type, description, and value, which is what you see over here. Right? Which is what you see over here. So instead of me going and creating these entities, I'm actually telling an LLM, okay, this is what I want. Can you please extract entities out of it? So entities are nothing but nodes, right? Entities are nothing but nodes. In order to build a graph, you need certain nodes, right? So you essentially want nodes out of it, fine. So the reason I said it is a thought experiment, because there are two ways to actually build this out. So hopefully I'm not confusing, and if you feel that you're losing track of what I'm trying to say, please stop me at any time. Fine. So there are two ways to build it. Just for the simplicity, I'm going to leave this on the screen. Fine. So wherein you have an entity extractor. This entity extractor is nothing but an LLM call. Fine. It is going to pass this prompt. And you see there's a text over here, right? Place here. This text is going to be replaced by this text over here. And now you get entities out of it. Now these entities are placed back or inserted into a graph database, which is what is a Neo4J comes in place, right? You actually are able to put it somewhere. So if you guys understand till that point, fine. So what we do now is that we do something called community detection. Fine. And we do community summary. Now the last two steps are not necessarily important. Fine. By important, I mean they are not part of your conventional GraphRAG. The community detection and community summary technique was introduced by Microsoft, right? and they had a paper called From Local to Global. There's a research paper which they wrote start of this year. It's called From Local to Global. So there they introduced a technique called query focused summarization. Fine. So this is called query focused summarization. What does query focused summarization means? It means that when I'm preparing or indexing my data so that I can make it optimal for retrieving or for certain type of queries, right? So one example is that I want to get a whole picture of my data, right? So if I have 10,000 PDFs, there's no way I can get a whole picture, even if I have a GraphRAG with me, right? So what do? I do something called QFS, which is query focused summarization, which basically forms groups of common entities and takes summaries of them, if that makes sense. For example, one of the entity is Paul Graham. There might be one more entity, which is his wife or somebody, his son, or, which is related to Mr. Paul Graham over here, right? Or some of his works or contributions. So basically all these entities are put into a cluster or a community, right? So maybe there are like 100 clusters together or 50 nodes together, right? Now what essentially happens is that instead of having 10,000 nodes, you end up with 50 different communities. Does that make sense? Instead of having 10,000 scattered nodes, now you have 50 communities, and all you have to do is that you have to take a summary of all the description inside a particular community, right? So let's say every community has 100 nodes within it. So you take a summary of all those 100 nodes, and you have a summary representing all those 100 nodes. You have one summary representing all those 100 nodes. Essentially, that is why we want to build this community detection over here. Now, what happens is that we take all those 50 communities and we find out what communities are similar to one another. We again perform community detection on top of established communities. So it becomes like a tree or a pyramid where you have one top level community or a summary, which is the summary for the entire document. As you go down the tree, you have even more detailed summaries, right? So it is basically a tree data structure. You get a tree out of it, and this tree basically has a document level summary and also a page level summary. Think of it like a PDF. So you have the entire PDF summary at the top. As you go down levels of the graph, what happens is that, or the tree, I should say, you start getting more specific summaries. At the end, you reach the nodes in each individual 100 nodes which you started off with. Now, this is the big idea which Microsoft was trying to propose. So QFS is not part of GraphRAG or Graph or anything. QFS is a separate technique, right? Graph is a separate technique. I mean, GraphRAG is a separate technique. These guys sort of brought them together. So if that sounds interesting, what we'll do is that before actually, let me actually see. Yeah, sure. Yeah, it works on vector also. It does work on vector, but we have to manually summarize different vectors. That's the only thing over here. Here we use community detection algorithm over here. I was going to talk about that. But once, after my demo, I'll talk about that. So we have a community detection algorithm over here, which is, there are multiple community detection algorithms. One of them is called hierarchical Leiden, right? This is interesting because hierarchical Leiden is the algorithm which lets us divide, or cluster all the nodes into different communities, which I was talking about. And this is the Rust implementation, right? Neo4J has an implementation also for the same, but I think it's only for enterprise customers. So you'd have to pay to access that. They have a separate system called GDS or Graph Data Science for Neo4j. So you can use that directly and you can use it, or there is an open source Rust implementation. You could also use that, and this also works perfectly fine. So I've used this to show you the demo today. Fine. So just a quick detour on how the community detection works, so that we are on the same page. So in order for the in order for the nodes to come together as one community, right, there should be some metric to say that these nodes are similar and these nodes are dissimilar. So that is what modularity helps us find. Fine. So again, I'll come back to this, but modularity helps us to find out like what nodes are similar and what nodes are dissimilar. Fine. So let me see if I can. Just give me 1 second. Okay. So this is a small chatbot which I built. Fine. So that I could actually. Oh, yeah, sure. Okay. So how do I compare a graph output versus a vector output? Yeah. So we actually judge it based on like at least like what we have done in our company, and it is still an ongoing process, which you rightly asked. So there's going to be a blog published on it. So what we do is that we judge it on 3 or 4 parameters. Like for example, how complete is the response, how precise is the response, and what's the recall, and the usual classification metrics. We actually put both of them through, and we actually have LLM as a judge in between, and we have a score over there, and we try to find out which answer was the best in answering the overall question. And we have exactly, yeah. Yeah. Mhm. Uh, in terms of performance, vector database is way better than the performance of graph due to reasons in terms of scalability, and also you can connect directly this one to the port. Yeah. I'll give you guys a quick uh, walk around this demo, and then we'll continue on our way. So this is just to give you a quick intro to both the responses, whether it is graph or naive based thing. So I have the same Paul's document over here. I'll upload it, right? And I have some embedding models, right, available to me. And I'll pick this, and I'll have the usual chunk size, and I'll have all the default values. So this applies. So whatever I'm doing here applies to both, whether it is the graph or it is the conventional RAG, it is going to apply to both. So I'll generate my embeddings over here. So let's pick an LLM. Like I'll pick GPT-4o. I'll have a value over here, right? And we'll have retrievers. So these are parts of RAG system, right? I've not gone through them, but if you get a chance, if you look at whether it is Llama Index or LangChain and all these guys, they have worked on similar fronts on the same thing, right? Whatever I'm showing this to a certain level, it's the idea is taken from them. So we'll go with the default retrievers, right? And I'll turn on the GraphRAG index over here, and I'll have sentence re-ranker to make sure that only the appropriate context gets filled in. And I'll run my setup over here. Now this is ready to work, fine. So I'll ask certain questions to both RAG and GraphRAG. We'll try to figure out which actually does better, right? So like we were speaking, you'll see the difference in the performance between a RAG and a normal RAG and a GraphRAG in a moment. So if I ask it, right? I'm asking it the summary of the entire document. So it gives me a picture. It says that the document narrates the author's journey through education, work, and entrepreneurship, right? It begins with the author's experiences in school. So it says something about Italy, working at Interleaf, right? And it says about his are expecting, right? Here you get sort of like you get an answer. It touches on all the points, but it's not very deep per se. But here you see that you have different headers and you have the detailing also within it, right? All this comes from the community which we were able to build, right? So once you have set up the community detection or communities behind the RAG, right? Once you do it, once you are able to set it during the indexing stage, what happens is that this comes in play when you ask, for example, when you ask for a generalist answer, right? Now we'll try one more query, right? We'll try one more query, which is more broader, right? So we know that Paul Graham worked on a language called Bell. So we'll ask, who is Paul Graham, right? And okay, so I'm trying to get a sequence of events, right? The question says that it's a two-part question, right? So this is also a common thing which RAG fails to address. It's called multi-hop questions. What is multi-hop questions? When you have more than one question in a single question asked. Like there's an and part, so it's basically two different questions, but you have asked it at one single thing. So multi-hop questions is where usually your conventional graph fails little bit to answer it. That's why things like agentic RAG, wherein you can make multiple calls, right, till you get the desired answer. So things like that actually help you out. Now, if I was to ask this question to my, naive RAG or NRAG, which I've called over here, it would give me an answer which looks like this, right? who worked on creating a new Lisp called Bell. Before he found Bell, he worked on. So this is decent. This is not bad, but we need the sequence of events, right? So let's, hopefully this works out. Let's see. So by the time this gives the answer, I think, we could even conduct a mini Q&A session. So this does take time. I do understand that. But if you do see here, so it does give me the entire sequence of events, right? It says that he co-founded ViaWeb, right? He had influence over Interleaf. He founded Y Combinator. Then he moved to England. That is where he started continuing his work on, the Bell programming language. And it also talks about Paul Graham's career as a whole. Now you see I hope you could see the difference when it comes to questions where it is more broader, right? When you want the entire, data set, where you want the, RAG or the LLM to understand the entire data set. Fine. Usually what happens in RAG is it starts picking out. So, for example, if I run this back with, this is just to, so this, it would be able to answer really well, right? So if I have a question like this, wherein it is a very straightforward question, right? Who is Paul Graham, right? A very straightforward question. Both GraphRAG and RAG would give the sort of a same answer. I would say that if you are using it for simplistic, deterministic queries, you should go with something like a normal RAG or, other types of RAGs. But if you want something where you want to understand the entire data set, right? If I just pull this down, you'll see that these were the context which was passed to it, right? So you see, this was the context which was passed to it. And I asked about Paul Graham, and hopefully it talks about Paul Graham, but you'll see it also has a lot of other data, right? Paul Graham must be somewhere in here in between, right? It must have talked about Paul Graham, but these are the vector databases response, which is added to the LLM, which is generating the response. Now I hope now you understand why it causes hallucination. Why does it cause hallucination? Because even though it is giving you the right answer, the context which is passed to it, right? It has so many unrelated data, right? Nobody wants to know what was his deal for startups. Like, we just want to know who is Paul Graham, right? We don't want to know what was his deals for startups and all those things, right? So because of this, at times what happens, your LLM starts hallucinating because you have too much data, right? Even if I was to go and reduce this embedding size to, let's say, 125, right? You'll see a similar sort of response over there as well, wherein you have large portion of context which is unrelated to the question that is asked, right? Because of the chunking strategy. So chunking strategy is something which is still researched on. Fine. So this was the like the whole picture I wanted to give you with the benefits of using a GraphRAG, right? And just if we could just touch on this quickly, this looks scary, but it is not that scary, right? So modularity is an optimization function, right? So what does modularity exactly do? So modularity tells basically whether a particular node belongs in a community or not. Oops. Okay. Yeah. So modularity basically tells you whether a node belongs in a community or not, right? So I've broken down these terms for you, right? So these are this part which you see is the main term, right? And you see that M is the number of edges, right? You basically have M and N. M is for edges, N is for nodes. So how many edges do you have? What is the adjacency matrix and all those things? So to make it a little bit easier for, so that, everybody gets a good picture of this. So let's say this is an oversimplified graph, right? So you see that these are nodes, right? Node number 1, 2, 3, and 4. So 1 and 4 are connected, 1 and 2 are connected, 2 and 4 are connected, and 2 and 3 are connected, right? So if we plot this into an adjacency matrix, right? So 1 and 1 is not connected, right? I'll just put 0 wherever it is not connected. 1 and 2 is connected, yes. So I've put a 1. So I've just built an adjacency matrix going with the same logic, like start node and end node, is there a edge between them or not, right? 1 and 3, we don't have an edge, right? So I've put it at 0. So if we start doing this, we'll get an adjacency matrix over here. Now this matrix basically tells you how strongly your edges are connected. Fine. If you see a lot of zeros over here, that means that you have separated nodes, right? If you see a lot of ones over here, that means that it's very strongly connected. Does that make sense? It is a bit of correlation. So if we take an example, right? If we take this as an example, right? And don't worry about this for now, but if you follow through this, right? And if you look, u is equal to 3 and v is equal to 2, right? Just fine. Yeah. So v is equal to 2 and u is equal to 3. Now v is nothing but the node number 2, right? And u is equal to 3 is nothing but the node number 3, right? So what we are trying to say is that, so this which you see over here, right? This part which you see over here, this is this part, right? Does that make sense? This part which you see over here is this part over here, right? And there's 1 by 2 by e is nothing but 1 by 8, because we have like 1, 2, 3, 4 edges, right? And as per the formula, there should be like number of edges, right? So if I do that, if you could see this, AUV says whether, see, AUV over here means whether the node 2 and 3 is connected, which it clearly is, right? 2 and 3 is connected over here. So I've put in a 1 over here for that, right? This 1 comes from the fact that the node 2 and 3 is connected over here, right? And I have minus du by dv by 2 by e. So if I should put it in very simple words, it basically tells me the difference between the actual way nodes are connected minus sort of like a probabilistic way. If I were to redistribute the edges, right? If I were to just randomly redistribute these edges, how would it look? That's what this is trying to figure out. So this tells us how strong your network is, right? So this red which you see is one community. This blue which you see is another community, right? So the basic idea of community detection is to start forming groups like this. So if I want to evaluate how strong this community is, I need a metric like modularity to tell me how strong it is. Now, du and dv is nothing but degree of freedom, right? So degree of freedom of 2 is like 1, 2, and degree of freedom of 3 is like 1, 2, 3. So that's why you see like 3 into 2 over here. And by 8 is nothing but like 2 into 4 edges total. So once you calculate this over the entire matrix, you'll get a value like this. Now, I'm rushing over this, but like all you need to know is that if this is a positive value, it means that the community is good, right? If it's a negative value, the community is bad. So it tries to start adding nodes to a community till the value doesn't change, right? For example, if I add a new node and this value does not change, it stays consistently positive, right? Then I know that this is a good community and I stop over there. So this is how modularity works and your GraphRAG works as a whole. Thank you.